All right. So this was a bit unexpected, but typically once every semester or so, this happens. And it's just good that the technology exists so that we don't have to completely lose our class. I just hope everyone got the message. I did send out two copies, two messages. So what we're going to do here is go over that chapter 8 problem set. Actually, I do have a Zoom account with Purchase. It's just that I've forgotten what my password was. So I just grabbed this one because I remember. If you were wondering about that, I actually have several of these accounts. I just picked this one because it was convenient. But yep, all the schools give me one, but I don't have all the passwords written down. So anyway, so let me get this going. So this is the problem set. So here's what we're going to do. I'm going to work on the screen, as you can see, instead of writing obviously on a whiteboard because I don't have a whiteboard. And by the way, when this is all done, this recording will be made available to you. The way it used to work during the COVID was that what I discovered pretty quickly is that the Moodle does not actually have enough room. This is how it was explained to me, to store videos, because apparently they take up an awful lot of room. So what I was doing instead was I was using my own personal YouTube account. And so I'll continue to do that here. I'll show you where it is. Let's go to YouTube. And I haven't used it in a while, actually, since the COVID was over. So you come up here. Let's see. I go to my account, my channel. Yeah, here we go. So what I'll be doing is I'll create a category. These are called playlists, and you're probably familiar with this. And what I usually end up doing is having one for each class. And you can see there's still stuff left over from the spring. Met 1060, that was the spring. Probably I was sick that day too. And prior to that, when we were doing this all completely online, a lot of those are still here. Like, for example, the fall of 21, this class was still being run online. And so all the videos are actually still there. So all you have to do is go to my channel, and all of it is publicly available as far as I know. So you could literally watch, oops. No, those are music videos. Stop that. So yeah, they're all there. I just have to create a playlist for this video, and then then you can go look for it. But the way it's set up, I don't know, it's very strange. You apparently have to have the video already done before you can create the playlist for it. Who God only knows why, but so that's how we'll do it. Later on today, or maybe tomorrow, I'll set it up so that you can go look at the video if you need to, if you missed something, or for anyone who couldn't be here. Anyway, in the meantime, let's get back to this. And so again, what we're going to do here is go over the chapter 8 problem set. I don't know if this is going to take up the whole class or not. If it does, we'll carry on next time. But if not, we might go back and take a quick peek at chapter 11 again. Now, once this is done, the only hurdle that remains between us and having, believe it or not, a second midterm is the sample midterm number 2, which is posted on Moodle. And it's a lot of it is very similar to what you're seeing here, because all of the second midterm is based on chapter 8 only. Okay, it's a very standalone chapter. The topics in here are pretty much restricted to this chapter. So that's why I think it makes sense to have this be our second midterm. And then when we get back, we can choose a date to have it. All right, let's get started. So we have this box. So I set it up easier to keep track of our answers. And what's happening here is that in each case, we have principal, we have a rate, which is what we'll call lowercase, and T for time, and then simple interest is I. Hmm. I'm starting to forget how this works. I have the ability to turn off everybody's microphones. There we go. Okay. So there it is. Yeah, like I said, it's been a while since we've had to do this online. Okay, so anyways, I started to say, in all of these cases, one of the variables is missing. So we just have to figure out what it is. So for number one, for example, we're trying to figure out I. Now, the basic formula, I equals PRT, is the one we've been using to calculate simple interest. So, so for this one, we just copy exactly what you're seeing. Just don't forget to convert the rate into a decimal. And for this one, you multiply those out, you'll see that the simple interest over this period is $1,440. All right, it's literally just a question of multiplying P times R times T. And then number two is exactly the same. So we'll have 25,000 times 0.085 for 8.5% for 6 months. Now this one, you got to watch it because 6 months, you should put in there 0.5 for half a year. Don't put 6 in there. Otherwise it'll, you'll get the result you would get for 6 years, not 6 months. So that works out to 1,062.50. And note that when you're doing dollars and cents, you should round it to 2 places. Okay. Now, number three, that it's T that's missing. So algebraically, if you rearrange this equation, you'll see that T equals I over PR. All right, so this is just a simple algebraic rearrangement of this formula over here. Okay, so for this one, we have I is 1,800. Over the product of, oops, sorry, I copied the wrong thing. I, in this case, is 360 over the product of 1,800 and 10%. And so what that implies is that this is a 2-year investment. Okay. Anyway, if you're just joining in, you haven't really missed anything. And as I was saying to everyone that this one will be recorded. It is being recorded as we speak. And eventually, when I get a chance, I'll be able to post it, not to Moodle, because there's not enough space apparently, but to my own YouTube account, which again, I'll show you where it is. You should be able to find it. I don't really know how hard it is to find somebody's account on YouTube. But I will have a set of playlists where I will store our video so you can find it, because I have quite a few, as you saw before. Oh, where's my account? Nope, not that one. This one. Okay, your channel. You see, I've got all these videos. These are going back a ways to during the days of the COVID. And it's quite a lot. Oh God, I did it again. Yes, and so what I ideally would like to do is put a playlist up for our class, just because there's so many. Otherwise, you'd never find it. There's hundreds of them here. So, all right. Anyway, let's get back to this. So anyway, number 4 is also time. So we use the same formula, I for PR. So we'll have 72 divided by the product of 600 and 0.04. And that's 3. So in that case, the time frame is 3 years. Okay, so just again, all you're doing is copying out of these cells. So for this last one, I took the interest of 72 and divided by the product of these two. Always converting the rates into decimals. Right. Now, the next two ask us to solve for the rate. And again, if you rearrange this formula algebraically, you'll see that R equals I over PT. And so that means in this case, you'll have 1290 over the product of 4,300 and 6 years. And if you take out your calculator, you'll see that that's works out to 0.05, which of course is 5%. So what it's saying is that if you borrowed $4,300 for 6 years, and the bank charges you $1,290 worth of simple interest, that implies that your rate of interest is 5%. Okay. What else do we have here? All right, the next one is exactly the same. It's another rate question. So we'll have 45 over the product of 203. And that worked out to be 0.75 or 7.5%. Okay. So again, we're just literally taking I and dividing it by the product of P, 200, and 3 years, or 600. And that implies that the bank was charging us 7.5% for this loan. Now, the last two ask us to solve for P. And again, you can certainly do so by rearranging this formula algebraically, and you'll see that it's I over RT. So in this case, I is way over here, 354.60. Over the product of R. Oh, here's a chat. I forgot you can do chats here. Oh, that's all right. I know this is all the very last minute. It's fine. This is all being recorded just in case you missed something anyway. Yeah, God, it's been so long since I had to do this online. If you have questions, you can turn off your, well, actually, you're all muted. I guess there's a way, what you can do is you type a question into the chat box, and all of a sudden I see a little red number here, and that means somebody's trying to ask a question. I think there's also a method where you can punch in a little button that looks like a little hand. Like you're raising your hand, but I'm not sure about that. So, but anyway, in the meantime, oh, there it is. It does. So I'm not seeing the little picture though. Do you really want to ask a question, or are you just showing how it works? It's just strange because sometimes it has a little actual physical yellow hand, and then I can actually see it, which is kind of nice. All right, we'll make this work. Okay. Yeah, no hand. All right, that's fine. Okay, and this whole thing is kind of in the way. I'll just shove it over here. Oh, here we go. Okay. Just showing it's under reactions. Okay, good. Thanks. Yes, because I couldn't remember how that works. But you can also just type. If you type in the chat room, there'll be a little number here. And since it's in red, I should be able to see it. All right, anyway, so let's finish this one. 354 is divided by R times T, 0.09 times 4. And that's going to give us 985. So what that means then is that if we borrow money at 9% for 4 years and we are charged $354.60 in simple interest, that implies that we must have borrowed $985 in the first place. Okay, and then the last one is exactly the same. E equals I over RT. 65,625 is divided by the product of 15% in 7 years, or 62,500. Whoops. Which indicates that we would have borrowed 62,500 in the first place. All right, so I'll give you a minute to catch up here. So, oh, that was the other thing too that was nice about being online. With a whiteboard, it all disappears. The document that I'm typing up right now in front of you, I can now save it and I can post it on Moodle. So there's a double advantage of this. I mean, all other things being equal, obviously we'd rather be in the classroom, but when it's not possible, we get two advantages. We get a copy of the solutions, and we also get the video if we need it. So it's not all negative. Not only that, but look what happens to your commuting time. It gets cut rather sharply. All right. So I'm going to assume that everybody's caught up. And then what we're going to do now is calculate the future value based exclusively on simple interest. So you might recall there's a very simple formula for this. And let me just repeat it for you. I'll write it right here. What we're going to do in all of these cases is type A equals P times 1 plus RT. Okay. So that implies that we're being charged simple interest only. There's no compounding taking place. So for the first one, number 9, A equals, so because P is 800, we multiply that by 1 plus, now R of course is 4%, we multiply that by 5. You're actually multiplying 800 times 1.2, which is 960. Okay, let me just boldface these so we can see it later on. Number 10, now they're all exactly the same then. So this is, oh, sorry, it's 15,000. I made a typo here. And so we end up with 24,450. All right, 11, A equals 700 times 1 plus 10% for 6 years. And that's going to leave us with 1120. There we go. Okay. And then finally, number 12. 1250 is multiplied by 1 plus 5 times. Here we go again. 6 months. Make sure you convert that to 0.5 years. Don't be deceived. 1250, it's so easy to make a mistake on something like that. So that means you're actually multiplying by 1 plus 0.0425, which leaves us with, if you round this to dollars and cents, it's going to be 1303.13. Okay, it's actually 0.125, but the bank would round it to dollars and cents. All right. All right, so again, I'll give you a minute to catch up. Now, most of these following questions, you notice there's a bunch of word problems coming up. Pretty much they're all going to be similar to the ones we just did. It's just that they're expressed a little differently. Okay, so let's say, for example, let's look at this one. In addition to working and her family's contribution, Jane had to borrow $8,000. So her principal is 8. 6 years is her time frame. And her simple interest is 4046.40. Find the rate of interest. So based on what we did above, that's this case. Okay. So there, you're being asked to take the simple interest and divide by the product of the principal times the time. And so that gives us 0.0843, which is 8.43%. That's how much she's being charged. So it's just exactly like the ones in the box, except it's a word problem. But if you read it carefully, you'll see that it's no different than what we were doing before. Well, all right then. How about 14? What's going on here with Fred? He's starting up a new e-commerce business. He's borrowing $15,000. That's our principal. It's 12 years. Oh, it's another interest rate problem. The simple interest is 18,000. All right, how much interest is he being charged? 18,000 is divided by 15,000 times 12. And so that implies a rate of 10%. Okay, so it's exactly the same, except that the numbers are different. And of course, on the calculator, be careful, make sure the denominator has parentheses, otherwise you'll get the wrong answer. If you're consistently getting the wrong numbers, you may be leaving out the parentheses. Okay, that's why I put them in there. Algebraically, it should be written like that anyway, but on the calculator, you're going to take 18,000 and divide by open parentheses, 15,000 times 12, close parentheses equals, and that will give it to you. Without the parentheses, it'll think you mean something different. And you'll know right away, because if the answer you get is way off, that's usually often a sign that you've forgotten your parentheses. Okay, if it's slightly off, you may have just made a simple typo. Okay, now here, this one is a little different because we know the simple interest. The rate is 9. The time is 3. Now we're asked to calculate the principal. So again, way back up here, you'll see that we did this already. And we are being asked to divide the interest by the product of the rate times the time. And so that works out to be $5,000. Even, okay? So that means that we must have borrowed $5,000. Yeah, they must have been the little ones that you buy for your home. They can't be that big for $5,000, but for a personal printer, that's a lot of money. But they must be very nice desktops. They're not the gigantic ones you see, you know, that make thousands of copies every hour. You know, the industrial strength ones. These are, but they're nice printers. Okay. So here, Williams Muffler Repair had to borrow $4,500. They paid a rate of 9%, 9.5% rather, and the interest they paid is $1,282.50. So T, by the way, when you see this term, it means how long does the loan last? Term and time mean the same thing in this context. So this is a time problem. Okay, so term just means time. How long until the loan is due? So we go back to the top and say, oh, that's right, we did one of these. Yes, we did. And if not, we could figure it out ourselves from the original simple interest rate formula. All right, so we've got 1282.50, 4,500 times 0.095. And so we have 3. It doesn't look like it. Those numbers do not look like they're going to turn into something really nice, but it's exactly 3 years. How interesting. All right, then. Now, this is the last one of these. So now it's another term loan. I can see it. They borrowed $86.50. The rate is 6.8%. And the simple interest is 441.15. And so T equals I over PR, which is 441.15 over 86.50 times 0.068. And again, it doesn't look like it's going to turn out evenly, but it actually winds up being, oh, it's not. Oh, look at this. Now 0.75 means 0.75 years, which is 9 months. Okay, so they didn't need the money for very long, but 0.75 is a perfectly valid time. It's very unusual that you only borrow money for 9 months. Usually a loan of this size would take place over at least 1 year. That's right. Oh, sorry, you're right. I did type it. After all that, I typed it wrong. Thank you. Jesus. Okay, good. Very good. But it happens, what if the company just needed the money for a short time and, it can be done. Banks, it can be arranged to have loans. If you have a line of credit with the bank, they'll lend it to you for any length of time that you ask for. Sometimes in businesses, they need money for long periods of time. Sometimes it's just a temporary thing. So it is possible for it to only be 9 months. Now, if you're borrowing money for a car, that's a different matter. It's typically going to be 4, 5, maybe 6 years, or a house. Typically, it's either 15 or 30 years because they're very expensive investments. But with a business, they need small amounts of money on a regular basis to cover their expenses. And so you never know what kind of deals they can make with their bank. All right. Now, these are the tricky ones. Okay. Now we're talking. This is probably the most complex set of questions we're going to run into today. Well, maybe not. I shouldn't say that. They're among the most complex ones. So for these, now I have this amazing device here. Even though this is a PC and you can't actually write on the screen, I have this tablet that actually does let me write on the screen. So we're going to do exactly that. Ooh, look at that. I could even draw a picture if I wanted to. So what are we trying to do here? We're going to use this formula. Look familiar? It sure does. This is the formula we use to calculate future values when there's compounding. Compounding is more frequently either the compounding takes place more than once a year, or else the time frame is more than 1 year. Either one requires us to have this formula. So for 18, he is 825. R is 4%. Now, these frequencies refer to N. So just remember, that is what tells us where N comes from. All right, then. Why don't we plug those in and see what we get? So I always think your best bet is to simplify before you attempt to use the calculator. So now, here's my calculator. What you probably should think about doing is calculating 1.04 to the 10th first, and then multiplying the result by 825. I think you're less likely to run into trouble that way. And if you do that, you'll have this is approximately 1.480244, let's say. And when you multiply that by 825, you'll have 1221. And remember, we can round this to dollars and cents, 1221.20. Now, we're not done though, because we're asked to also determine how much interest we earn, how much of that is simple, and how much of it is compound. So if the future value is 1221, when the principal was 825, the interest is the difference between the two. Which is 396.20. The simple interest, as you know, is PRT, which is 825. R is 4, and T is 10 years. So the interest is 330, simple interest. The compound interest must be the difference between the two. Actually, let me change this to total interest. There you go. And that's the compound interest. Okay, so this is how it's done. Once you've calculated the future value, you need first to figure out the total interest, which is the difference between these two. Because what you end up in the future minus what you started out with is all interest. But we also know that simple interest, I equals PRT. In this case, it's 330. So therefore, the extra 66.20 that we got must be compound interest. So they're all going to be exactly the same. All right. So actually, you know what I'm going to do? Let me split the screen so we can see what we're doing. I'd like to have, the box available right there. All right. Now for number 19, what do we know? All right. Well, P is 3250. R is 2%. Compounding frequency is once per year. And it's a 5-year investment. So we'll start with the formula for the future value. So 3250, 1 plus 2% compounded annually for 5 years. So we can simplify that. So 1.02 to the 5th power is approximately equal to 1.104. It's almost exactly 1. Let's try 1.10408, let's say. When you multiply that by 3250, rounding to dollars and cents, It's 3588.26. Okay, now the rest of it is, will follow along with exactly what we did earlier. In fact, just because I've been typing this, I'm going to copy this and just make the changes. No point in starting all over again, except that A is 35, P is 3250, $338.26. The simple interest is 3250 times 2% for 5 years, 325. So the difference between them is what we're looking for. $13.26. Okay, so that's that one. See, okay, so the next one is 20. All right. So I'll start. You should still be able to see enough to catch up if you're not quite there. So once again, we have our favorite formula. Oops. So this will be a small one, 1 plus 0.02 twice a year for 6 years. So 1.1 to the 12th is approximately equal to 1.12. Oh, come on. 1.12 6825, let's say. We probably don't need that many digits because it's only $75 and we have to round to dollars and cents anyway. So, but anyway, we have 84. Oh, wait a minute. No, something's not right. Number 20. Oh, I copied the wrong interest rate. Sorry about that. I just realized that I was looking at the wrong spot. This is 3%, not 2. So let me fix that. It's 3. Yeah, I was looking at the wrong row. It's 75. But yeah, because this is number 20 now. 3% semi-annually for, yeah. So unfortunately, I copied the wrong interest rate. So let's fix that. Okay, so it's 3. Half of that is 1.105. Still raised to the 12th power. 1.015 to the 12th is 1.195618. And when that's multiplied by 75, you get 8967. All right. So just like before, I'm going to copy this setup, just make the necessary changes. Okay. A was 8967. P was 75. So the total of 1467. Now the simple interest is not going to be very much. 75 times 3%. And it was for 6 years. So that's equal to $13.50. And so we end up with 1467 minus 1350. So the total compound interest is only $1.17. But remember, it's a very small amount to start with, only $75. All right. So once you get, once you've done a few of these, they're all the same. The only thing that really changes is the numbers. So if you're careful with the calculator, and in my opinion, if you do the simplification first, followed by doing the exponent first, you should have no problem with it. All right. So now we're ready for 21. I'll leave that there for now. P in this case is 1550, R is 5%. And the compounding frequency is 2 and T is 7. All right, what do we have? 1550. Oops. One plus 0.05 over 2. 2 times 7. When you simplify that, it's 1550 times 1.025 to the 14th power. And that's approximately equal to 1.41293738. Multiplied by 1550 is 2190.11. Okay, so the future value is 2190.11. So I'll come back up here and borrow this setup. So the future value is 2190.11. Principal is 1550. Okay, so that one is 640.11, of which the simple interest 1550, 5%, 7 years is 542.50. So the difference between the two is 97.11. Okay. Oh, wait, sorry, it's 97.61. Nope. There we go. That's better. Okay, now we're all set. Mm. All right, looks like there's two more. Okay, but they're all exactly the same. Okay, so let me just get started on 22. E is 25.75. R is 4%. N is 4 for quarterly, and it's a 2-year investment. Okay. So we'll scroll up so I can write this down. Oops. Okay, here we go. $25.75. 1 plus 0.04 over 4. And then we have 4 times 2. And then we have, simplifying it, okay, so 1.1 to the 8th. 1.08 2857, let's say, or 567, that's fine. All right, multiplying that by 25.75 gives us 27.88. Wait, 27.88. Wait, oh boy, did I do it again? Yes, I did. I copied the wrong thing. Sorry, it's so awkward doing it like this. I just realized I copied the wrong principal. 625. I copied everything wrong, didn't I? No, you know what I did? I copied 23. That's what happened. I'll tell you what then, let's do this. Rather than starting it all over again, what I'm going to do is just save this because it's right. It's just the wrong number. So let me just, let's try that again. 22. Is actually, so we'll come back to that one. Let's put it that way. P is 625. R is 8%. N is 4 and T is 12. That's much better. All right, so that's the actual number 22. Okay, so now we're getting there. So I have 625, 1.02 to the 48, And that's about 2.58707. Okay, that's close enough. And then we end up with 1616.92. Okay, great. So now you can just copy this setup. So we have 1616.92. The principal was 625. Now, the reason why the spread is so great is because this is a long investment. We're looking here at 12 years. So that's why there's so much more interest than principal, or why it's such a large amount of interest. All right, here we go. 1616.92 minus 625. The difference there is 991.92. The simple interest PRT is 625. The rate in this case was 2%. No, it was 8. That's right. It was 8 for 12 years. And that's $600. Okay, so the rest must be the compound interest. So we have 991.92 minus 600 minus 391.92. So if you notice in this case, the compound interest was quite large compared to the simple interest. In all the other cases, it was a very small amount. And that's because, first of all, it's a high rate of interest. And secondly, it is 12 years. And as we've seen in class, the more time that goes by, the simple interest grows at a steady rate, but the compound interest grows at a very rapid rate. And so eventually, you'll have more compound interest than simple interest. All right. So now we can get to this one that I started to do by mistake. 25.75, 4%. Yeah, this one is correct, but what happened here? So I'm just going to multiply that one out. $25.75 times 1.0828567, 2788.36, rounding to dollars and cents. Beautiful. Oops. Now, let's just grab all of this and make the necessary changes. It's too bad you can't do this at home, right? You can't just copy. Well, maybe you can if you're typing instead of writing by hand. But if not, well, you can always use these. You can copy these if you want. Like I said, you'll have a copy of this that you can use as your study guide. Okay, so this time we have 2788.36 minus 25.75, which is 213.36. The simple interest is 25.75 times 4% for 4 years, 2 years. Yeah, this one was only 2 years. That's why there's so little interest, by the way. And that's 206. And therefore, we have 2788.36 minus 213.36. That's better. Minus 206 is 736. All right. That should do it. Hmm. All right. Now the next batch of problems involves annuities. Okay, so that's a very complicated formula, but we're not being asked to do anything else except calculate the actual future value. So it's not maybe as time consuming. It's just that we have to be more careful. Okay. All right. So we just run through here and make sure everything is all set up. One of the awkward things about this writing on the screen, though, is that if you're not careful and you hit the wrong button, it can get pushed around into different pages, and then it can start to get all mangled and squeezed together. And unlike the text itself, which can't really be affected, this stuff, it's like a picture of some kind. And if you're not careful with it, even something as simple as changing the pagination can really cause quite a mess. So I'm just making sure that everything looks right. Now, the other thing too is once I save it as a PDF file, though, it'll never change again. So I'll be posting both this and the PDF version, especially if you have a Mac. The thing is this, of course, I'm doing this on a PC. You can probably tell just by looking at the buttons down here, but sometimes when you try to switch back and forth between the two platforms, special items like pictures and handwriting and equations and symbols even can cause problems. And so if you have a PDF, you're basically seeing a picture of the original results. So if you open up the Word document and you can't read something, go ahead and read the PDF version. Okay. All right. Yeah, everything looks good. All right. Now down here, what we're doing is calculating. Now, if you notice, it actually says the word annuity. So there's a magic word annuity right there, which implies that this payment listed here is going to happen every period, not just once. Okay. So for 24, R, remember we're using capital R to represent the payment as opposed to P for principal. And the frequencies are the same as before. In other words, annual means once a year. Here we have twice a year, and then these are quarterly. Okay, so we need that. Now the formula, though, is a little different than what we've just been using. A equals R, open parentheses, 1 plus R over N to the NT power minus 1 over R over N. So yeah, the challenge here is just plugging everything in and then simplifying. So let's start by simplifying it. So probably what you should do is figure out this value first. Okay, and then multiply by 200. And then when you're done, divide by 0.09. So if you calculate 1.09 to the ninth power minus 1, you should get approximately 1.17 189. That's probably good enough. All over 0.09. Now it's easy. Just make sure you multiply those two numbers in the numerator, divide the whole result by 0.09, and within dollars and cents, it should be approximately 2604. Let's round that up to 21. And that's it, you're done. So we didn't ask for anything except the future value in this case, right there, just the future value. There you go. So make sure you're getting that. In fact, I'll tell you what I'm going to do here. Since my throat is getting very dry, why don't you double check your results? I'm going to go get something to drink, and I'll be back in a second. All right. Let's do the next one. So I'm going to split the screen so I don't have to go back and forth 100 times. If you're new to a Word, what you're doing here is view. And of course, anytime you write a paper, you'll probably end up using Word or the Mac equivalent of it, which I don't really know. But if you go to view and hit split, you can break it up into two sections. And that way you can keep an eye on one of them. So I've got to watch it though. This is how I got into trouble before. I copied the wrong information. All right, so here we go. Number 25, R is 750. Oh, you know what I forgot to do? Let me label these. Okay. Just so you know, recognize the values or variables in the formula. Okay. There we are. Now, R 750, that's the repeated payment. All right, so we're just going to use the same formula. All right, here we go. A equals R 1 plus R over N, all to the NT power minus 1, all divided by R over N. Okay, so what does that give us? Okay, then when we simplify it. All right, so what I'm going to do now is calculate 1.03 to the 12th power minus 1 point 4257 61 All right, we multiply that by the 750 divided by 0.03, and you should get 10,644. .02. Okay. That's it. All right, if you have a mistake, let's double check. Now, of course, you know, this is not the only way to do this, but I think it's the easiest. All right. So as long as you plug in the correct numbers and you simplify properly, it should go pretty smoothly. Okay. Now, next is 26. We have, again, R is 1250 this time. R is lowercase r is 0.068, N is 2, and T is 3. All right, so the formula that we are almost know by heart by now. Of 1250 is multiplied by 1 plus 0.068 over 2. The exponent is 2 times 3, all divided by 0.068 over 2. All right, we'll simplify it. We have 1.034 to the 6th power. Okay, minus 1, all divided by 0.034. So 1.034 to the 6th minus 1. Is 0.221. $222,146. Okay. 1250 times 0.222146 divided by 0.034 is 8167.13. Or 14. Close enough. 13 or 14, depending on how much rounding you did. All right. That was 26. All right, 27. I'll start to do that one here. R equals 375, lowercase r is 0.05. Now this time the compounding is quarterly and the time is 4. So we'll have okay, so that should take care of it. $375 is the repeated payment, which is made every quarter for 4 years or 16 times. And now, when we simplify, 5% divided by 4 means 1.25% per quarter. So we've got 1.025 to the 16th power. Minus 1, of course. All divided by 0.0125. All right, 1.0125 raised to the 16th minus 1. 0.219. $88.95, let's say, divided by 0.0125. Okay. All right, let's see what that turns out to be. Um, 65.96. 68, 69. Okay, very good. And of course, you might have gotten, if you rounded in that, and you notice in the parentheses we're rounding, the more digits you leave, the closer you'll get to the actual number. So if you're off by a penny or so, it's just rounding. If you're off by more than that, you may have made a typo or copied something wrong. And of course, if you're way off, you may have been not careful with the parentheses. All right. So there's let's see, what was that? 27. Oh, there's only one more of these, and then we'll move on to something quicker. Let me just get 28 set up. R is 1530. Lowercase r is 0.045. 045. Be careful with that. N is 4, and T is 8. Okay. Yes, 0.045 is 4.5%. If you do that wrong, of course, you cannot possibly get the right answer. Okay, now this one is going to need a little cleaning up here. 1530. Let's see. .045 divided by 4 is 0.1125. So it's 1.01125 here. Raised to the 32nd power minus 1, all divided by 0.01125. Beautiful. All right. So that leaves us with okay, it's about 0.43 045 14. Okay. All right, let's see, times 1530 equals divided by 0.01125. All right, so with dollars and cents, it's 58,541.39. All right. So that group is done. Now what's coming up next is the EARs, which are very simple compared to this. Yes, by comparison, they're a breeze. That's right. We've already done the hardest ones by far. Although there's still some tough ones coming up. So let's see what this is all about. What do they want us to do? Let's unsplit the screen. Let's see now. Here we go. So they're giving you two things, the APR. This rate is the APR or R. And of course, this is the compounded frequency. N is 4, N is 2, N is 4, N is 2. So what they just want you to do is calculate the EAR. Now, if you recall, the EAR formula is this. E equals one plus R over N to the nth power. Okay, just be aware that R is the APR. N, of course, is the compounding frequency. And E itself is the EAR. All right, so for example, number 29. R is 0.06, N is 4. Now, if you notice, in these cases, we don't have T. It doesn't matter how long the money is left in this account. It does not affect the way EAR is calculated. I just realized I forgot the minus 1. Yeah, that kind of helps. All right, so 1.015 to the 4th is 1.06136. That's enough. You don't have to round it any further than that. In other words, because this is 6.136%, that's quite enough. If you go to a bank, they'll typically round the interest rate to 2 decimal places anyway. I guess not always, but that's pretty standard. And so you don't have to go any further than that. All right, and that's all there is to it. Look how easy that is compared to the other ones. I mean, really. All right, now 30 is 10 and semi-annually. Oops. Which means that n is 2, of course. Man, so it's been my experience that most people do a lot better on the second test than the first one. And you can kind of see why, because it's less material, but also because it's very straightforward. I mean, there's no mystery about what you're supposed to do. So this is 0.1025. Okay. And also don't forget too, just pay attention to this. APR, whatever APR is, EAR will always be higher than that. Okay, so if you have something like here, if I had 9 something, then I know something's wrong. It's possible for them to be equal to each other, but EAR normally is higher than APR. With 31, we have 6.5% and quarterly. So what does that leave us with? All right, so I'll have, in this case, so you should go ahead and simplify it a little. 0.065 divided by 4 plus 1 is 1.01625. Sorry, raised to the 4th minus 1. So you're looking at 1.0666. It's rounded to it's almost exactly 666. Well, all right then. I think there's only one more. 32. I'll just copy it down here. Okay. All right. So as of course, E equals 1 plus R over N. So it's 1.04775 squared minus 1. So we end up with 1.09778. That's it. Or of course, 9.778%. So those are all the same. Now there's a handful of problem sets down here. And they're very similar to the ones we've just been doing. The question is, which one is which? Let's just take a look at these real fast. Now, number 1, this one says, a couple decides to set aside $5,000 in a savings account for a second honeymoon. It is compounded quarterly for 10 years at 9%. How much will they have in 10 years? So clearly this is a future value problem. So that means we have to ask ourselves, is it an annuity or not? But then doesn't say anything about $5,000 going into the account more than once, which means it's not an annuity. And we're going to use this formula. We're going to use the formula that involves principal. Okay. That one, yes. Okay, not an annuity. So we'll have oh, see now I accidentally erased it. 5,000. Well, that's something I can't do in the board, can I? Here we go. So I accidentally erased the 5. It's $5,000. That's our principal. It's 9% compounded quarterly. And it's for 10 years. Now, 9% divided by 4 is 2.25%. So we have this. So you get 5,000 times 2.4. Oh, what was that? All of a sudden I looked up and there's a bunch of fuzz on my screen. What is that? 2.4351. 889, 890, let's round it to. So that should give us 12,175.94, let's say. All right. So the key to the whole thing is that it's a future value of a sum, not of an annuity, of a sum. And so then we just plug in everything the way we're used to. All right. Now this one, the parents of a child invest $20,000 in a bond. Ooh, this one's kind of tricky. That pays 8% compounded semi-annually. In other words, this is a different situation because this bond generates cash flows twice a year. So this is, oh wait, no, it doesn't. Sorry, hold on a second. No, sorry. It's $20,000. The interest, it's only the interest that's being repeated. So it is not an annuity. So it's a $20,000 bond that generates 8%, but the interest is compounded semi-annually. So in other words, they're really paying us 4% twice a year. And it's twice a year for 18 years. So in other words, it's a baby. They're saving for his college, all right? That's not unusual. Parents of newborn children often are given gifts. They're designed to help them save for college. Because you can imagine what college is going to cost in 18 years. I don't even want to think about it. But if you have a bond, I mean, if you start an investment now, it could be worth an awful lot of money in 18 years. So let's check this one out. Wow, 4.10, 393, 255. Now, what this means is this number tells me this 4.1 means that for every dollar we started out with, in the future, we'll have $4.10 basically. Which, you know, it's a lot of money. But that's because it's an 18-year investment. And 8%, let's face it, is a very nice rate of return. All right, so that's good. That should help. Maybe in 20 years, SUNY purchase will cost that much every year. Who knows? The rate things are going. Now, this one is different because their the husband and wife are saving for their daughter's college in 4 years. Now they're behind the 8 ball. They have to save money every year for the next 4 years. So the key here is that they're making payments not just once, they're putting money away twice a year for the next 4 years. They've got a lot of catching up to do. Okay, so this is an annuity formula. All right, so it's $22.50 that they're putting away. The rate is 7.5 twice a year, 4 years. All right. Uh-oh, what's going on? There's a chat. Oh, okay. Yes. Yes, I'm sorry. I don't want to hold you up. I just wanted to finish this up for next time. Here's what you do though. For next time, at least start the sample midterm number 2. So because I'd like to go over it next time, and I'll see you next time. And if you missed anything, you can watch the recording or else look at these answers. Yeah, I know we're a little behind right now, but I just want to finish this up rather than having to do like the last 2 problems on Thursday. Because I know you're not at school right now, or you're in your room somewhere. All right, so we're going to have, this turns out to be, I'll just tell you, it's 20,548.25. And then we'll just do the last one and we'll be done. Okay. All right, one more and then we're done. Now this one, it's an annuity. It says the word annuity. Okay. um 600 quarterly, 8% 4 times a year, but for 3 years. All right, so since we're running out of time, well, let me just quickly simplify it for you. And that works out to about 8047.25. There you go. All right. So we're done with this whole thing. So here's what we're going to do. For the next class, we'll go ahead and at least start the sample midterm. It's going to be very, very similar to this one. Because of course, it's just the one chapter. All right. Now, that doesn't mean we have to have the test right away, but I'd like to get this out of the way so we can dive into 11 again, which 11 and 12, as you know, are the last 2 chapters of the semester. And then we'll have our final sometime in mid-December. All right, so I'm going to save all this, both as it is and in a PDF format. I'm going to post these on Moodle, and then when it's ready, I'll take the recording and put it on my YouTube channel. All right, so then hopefully I'll see you in person on Thursday. If not, I can hardly imagine. I mean, it's not like I'm sick. I'm just not sick. And I mean, I didn't want to come into the room and sneeze all over you. So I'm pretty sure I'll be ready by Thursday. So I'll be seeing you then, and we'll do this the sample midterm in person. All right, so I'll see you all then.
Thank you.
Goodbye.